Hello everyone, myself Dr. Feroza Demirachkar, and today we will see a 8051 program to find the square of a 8-bit number. Here, this program calculates the square of a number stored in the memory location and writes the result to subsequent memory locations. The primary purpose of this program is to calculate the square of an 8-bit number stored at a specific memory location and store the result, that is 16-bit result, in two consecutive memory locations. Because we are multiplying or we are squaring an 8-bit number, it can yield the result as a 16-bit number. So here we will store the result in two consecutive memory locations. These are the general steps of the program. First is initialization. Here we'll set up the memory pointer to point to the memory location where the input number is stored. Then next step is loading the input. Here to retrieve the input value from the memory, and we'll move it into the accumulator A. Okay, that is, we'll retrieve the input value from the memory, that is, we'll take the input value from the memory and we'll move it into the accumulator A. Then we'll call the subroutine. So here this will jump to the subroutine to perform the square calculation. Then the subroutine will calculate the square of the number, and here it will use the multiplication instruction. So here it will multiply the value in the accumulator by itself, and then the result will be stored. So the result will be stored like here in the lower byte, that is we'll store the lower byte in the accumulator. Okay, and that is, we'll store the lower byte in the memory location next to the input which we have given. Suppose we have given the input at 30H, we'll store the lower byte in 31H, and we'll store the higher byte in 32H. Okay, that is a consecutive memory locations. Now here, why we are using the multiplication to find out the square? We can do that. That is, we can find out the square, or we can compute the square by using a loop which will add the number to itself multiple times. But a more efficient way is to use the multiplication instruction. So we are going for multiplication. Here we'll see the logic of the program. What we'll do is we'll load the value into the into R0. Then we'll move that value, that is move data, to the accumulator. Then once we are done with the initialization process, we will call the subroutine, that is the subroutine execution. Here in our program we have named the subroutine as SQR. So here it is SQR, call SQR. We'll be calling the subroutine, and here in the subroutine we'll be calculating the square of the given number. Once this is done, we'll store the result in the memory and update the register. So the three main steps are the initialization, then subroutine execution, then the data storage. So here we'll see the program. Okay, so the program starts at memory address 0000H. Then move R0, #30H. Here this will load the address 30H into the register R0. So the program begins at memory location 0000H, and the register R0 is initialized to point to the memory address 30H. So that is where the input number is stored. Then next is loading the input. So for that we are using the instruction move A, at R0. So here here we'll be loading the value from an address 30H into the accumulator, and then we'll call the subroutine. So here L call SQR. Here this will call the subroutine to compute the square. Then the program jump to the jump to itself, creating an infinite loop. After the subroutine returns the program, enters an infinite loop, and it will halt the execution. Okay. Now we will go to the uh, subroutine. Okay. So here this will perform the multiplication. Now move b comma a. Here it will copy the value of a into b. Then mul AB, it will multiply A by B, and the result in A, that is the A will be having the lower byte and B will be having the higher byte of the result. So the accumulator value is copied into the register B, and the multiplication instruction, it multiplies the contents of A and B, and the lower byte of the result is stored in A and the higher byte of the result is stored in B. Then we will increment R0. So here we are incrementing R0 to point to the next memory location. The next instruction is move R0 at R0 comma A. Okay, so it will store the lower byte of the result at the next location. Then we will increment R0. So here again R0 is incremented to point to the next memory location, that is 32H. Then we have move A comma B. So the higher byte is stored at the memory location. The higher byte is moved to the accumulator. Then move at R0 comma A. Here the higher byte will be stored at memory location 32H. Then this RET, it is the program returns to the main loop. Here it returns to the main loop. Okay, so here it returns to the main loop, and the program will end. Okay, so here we are taking the input as FF at 30H, and we should get the output as like FE01. That is, the lower byte is stored at 31H and the higher byte it is stored at 32H. Fine. So here this is the flow of the execution. Now here uh, this is the main loop. Okay, so org0000H, it will set origin address. Then move R0 comma hash 30H, it will load the pointer value, and move A comma at R0, it will move the value to the accumulator. L call SQR, it will call the subroutine. Then it will enter an infinite loop. So after that, this is the subroutine SQR, which we have named as SQR, execution sequence. Here we are using first what? We are using move B comma A. So here this instruction will move the value in the accumulator to the register B, and this is done to preserve the original value of A for later use. Then we are going for multiplication. So this will multiply the values in the registers A and B, and the result of the multiplication is stored in the accumulator. That is, the lower byte will be stored in the accumulator and the higher byte will be stored in the register B. Then we'll increment R0. So here it will increment the value in the register R0 by 1. So earlier R0 was 30H, now it will become 31H. Okay, so here it will point, now R0 will move to point to the next memory location, that is 31H. Then we have move at R0 comma A. This instruction stores the result of the multiplication, that is the square of the original value, back into the memory location pointed by R0. Okay, then again increment R0 to point to the next memory location, that is 32H. Next we have move A comma B. So this instruction moves the value in the register B back into the accumulator. Then we have the instruction move at R0 comma A. So here this instruction stores the original value that is now in A into the memory location pointed by R0, and RET is it returns from the subroutine SQR, transferring the control back to the point where the subroutine was called. Then the program will be ended. That is, end directive indicates the end of the program. This is one example. So we have taken square as we have taken the input as 5. We want to find out the input, or we want to find out the square of 5. Square of 5 is 25 in decimal, and in hexadecimal it is 19h. So now divide 25 by 16. You will get remainder as 9, and the quotient is 1. So here the most significant bit, okay, or the nibble will be the quotient, okay, and the least significant bit will be the remainder. Therefore 25 can be written as 19h. That is, this is the most significant bit, that is the quotient, and this is the least significant bit, that is the uh, this is the remainder, and this is the quotient. Okay, so the least significant bit will be the quotient, sorry, remainder, and the most significant bit will be the quotient. And here this is the lower byte. Okay, lower byte is 19. So at 31h we'll be having 19, and at 32h we'll be having 00. Okay, that is the higher byte. So this is a summary of the execution. Here the program reads a number from the memory location 30h. Then it will calculate the square of the number in the subroutine, which we are calling, that is the SQR. Then the result, that is the lower bytes and the higher bytes, both will be stored in the memory locations 31h and 32h respectively. After returning from the subroutine, the program will enter an infinite loop. Now we will execute the program and see. So I'll copy the program from here. We'll open the Keel software. Go to project, new vision project. Then I'll use the previously used project. Yes. Search for the device microchip. Then click on the plus symbol. Then search for 8089C51. Okay. Then click on no. Now go to file. Open new file. Type your program here. I'll directly paste the program. I'll save it. I'll save it by SQR, that is square, SQR.ASM extension. Always you have to save your program with the .asm extension. Then go to target. So here target is created. Click on the plus symbol. So source group 1, you are getting source group 1. Right click on this. Then click on add existing files to group source group 1. Now type your program name. I have given it as SQR.asm. Selected. Click on add and close. Now see whether this program appears in your source group 1. Click on this plus symbol. So here it has been added to the source group 1, that is SQR.asm. Now go to the project. Click on build target. So you have 0 errors and 0 warnings. Now go to debug, start or stop debug session, then click on OK. So now here our input has to be given at 30h and output has to be checked at 31h and 32h. So here I will type as I:30h, enter. So I'll give the input as 5. I should get the output as 19. Okay. So here debug, run. So I'm getting 19 at 31h, that is the lower byte, and at higher byte it is 00. Okay, that is, this is 30, 31, 32. At 31h we will be having, at 31h location we'll be having the lower byte, at 32 location we'll be having the upper byte. We will see one more example. We'll give another input. I will give FF here. Okay. So you should get the input as what? FE01. So 01 should be at 31st location, that is the lower byte, and FE should be at 32nd location, that is the upper byte. So now go to debug, run. So here you are getting FE at the 32 location, that is the 32nd location, and 01 at the 31st location. So this is 30H, 31H, 32H. This is the lower byte and this is the upper byte. Okay. This is how you calculate the square of a number. Hope you all have understood the program. Thank you.